So now that we know that there's a random effect in everything that we look at, we need to think about how can we look at data and be able to draw conclusions from it. How can we figure out what's important and what is just random effect? So a lot of times in a monthly report, you'll see something that looks like this. This report has information on sales, including the volume of sales that we've done, the percentage that we delivered on time, and the percentage that were sent back to us. And then it also has information about production, how much we have produced, how many man hours it took to do it, and what the actual output was. The first column shows what actually happened in month 4, and the second column shows how much we were hoping would happen in that month. And it looks like the monthly target is not specific to being in month 4. It's just that if we did that much every month, we'd be fine. The third column is the first column that has some sort of judgment into it. This column is giving the percentage of difference from the monthly target to the monthly actual. So what it looks like is our sales are not what they needed to be. Our on-time delivery is not what it needed to be. The percent rejected is way more than it should have been. We didn't produce as much as we should. It took more man hours and more material than it should, and we ended up not producing enough. Well, that looks pretty darn dismal. But there are things that affect it that make one month different from another month. So maybe the problem is that it's the 4th month. So for example, if you're selling flip-flops, they don't really sell very well in February. So maybe it's a problem with what time of the year it is. So this column compares this year, month 4, to last year's month 4. And that makes it look even worse. Our volume is way down from month 4 of last year. Our on time was down from last year. Our percent rejected is way up from last year. Our production is bad. Everything looks bad from month 4 of last year too. Okay, so maybe the problem is that we're looking at just 1 month's data. Instead, let's look at the year to date. And so we have the actual year to date and the target for what we were hoping would be for the year to date. And when we look at that, the percent difference doesn't look that bad. Our sale volume is right where it's supposed to be. Our on-time percentage still isn't what we were hoping for. And our percent rejected is a little bit high, but not terribly high. The amount of volume that we've had to use is down, but we haven't produced quite as much as we should have, but we used less man hours than we were supposed to, so who knows, maybe it's all okay. So then we say, well, there is a monthly effect, so let's compare how we are this year to how we were last year. And we are ahead in our sales, still bad on our on-time percentage, but still bad on our rejected amount. Our volume is down, our production is down, our output is down, but our man hours are down too. So I don't know, is that better or is it worse? All of this analysis is missing one critical thing. When we see a difference, we have no idea of whether knowing that difference is significant or whether it's just part of the random effect in the data. There is some chance that every difference that this chart shows is really just random effect. And if, as a company, we react to things that are random effects, then our management will be random and our ability to do things will be random, and we're really not going to do well. So the bottom line is comparing any 2 sequential readings, any 2 readings that are a year apart, or in fact, any 2 point-in-time readings is really just showing us a random effect that is inherent to the process. We have no idea whether those differences are significant or not. And if we react to that type of data, then we're reacting to noise. So in order to understand if a change is significant, we're going to need to have an understanding of, for this variable in this system, what sort of variance is normal. So the simplest tool that we can use to look at data that has a random effect is called a run chart. And basically, it shows how the data changes over time. The center line is the average, and we plot the points in the order in which they were observed. With this kind of chart, we can see if any month-to-month change is significant, and you can compare what was month 4 a year ago to month 4 now, but you have the bigger context of how is the variation changing over time. It's a chart like this that you can see why we talk about noise and signal. The background variation that is inherent to the process is going to make this kind of chart look like the sound chart of random noise. And when something significant happens, you're going to see a signal in that noise where the shape of the graph changes in some way or another. So when we talk about noise, that is the random effect that is inherent to the system. And what we're always trying to do is separate that noise from the signal that tells us that something significantly different has happened.